Okay, pre-calculus. We are on Unit 7, Day 2. I'm going to try to do this in one 15-minute video. We will see what happens. So we're going to go ahead and start with polynomial function in just the standard form here where all the a's are real numbers and n has to be a non-negative integer. So it could be 0, 1, 2. The domain of the polynomial is the set of all real numbers. So I know you guys have seen this before, and if you're taking notes, go ahead and write it down and press pause whenever you feel comfortable if you need to write something down. So to identify a polynomial, it just needs to be in this form and following those rules. So a is a polynomial, even though we really should write this negative 3x to the fourth first. The highest degree should go first, but it's still a polynomial with a degree of 4. This one has if you could rewrite this as, or b, as x to the 1/2. That fractional exponent, makes this not a polynomial. C has a denominator of x cubed minus 1. It is not in this standard form of a polynomial, so that is not a polynomial. In D, we don't have a degree given at all. We can call it a polynomial. It follows this format, but take a look at E. Just the number 8. That just means x to the 0 power. So that's a polynomial and the degree is 0. For F, it's a polynomial, but the degree is actually 5 because if you were to rewrite this, okay, and then I were to go ahead and FOIL this out, right, and multiply all those 3 terms by negative x cubed, the highest degree that I would get is 5. There are 2 x's here, 3 here, for a total of 5. So you can multiply that all out if you'd like, but just knowing algebra, you can pretty much tell that's going to happen. So the properties of y equals x to the n whenever n is even. We did a lot of this with parent functions back in Unit 1, but now we are going to change the exponent and say, okay, when x is even, what happens, and when n is even, the exponent, what happens, and when the exponent is odd, what happens. When it's even, the graph is symmetric with respect to the y-axis. So, you know, like a quadratic. Here we go. Okay? Or to the 4th power. 1, 2, 3, 4. Okay, well, that's a terrible graph, but you get the point. It's symmetric with respect to here's the y-axis. Okay? The domain is the set of all real numbers. The range is the set of all non-negative numbers. And the graph always contains the points 0, 0, 1, 1, and negative 1, 1. Okay, that's because it's symmetric with respect to the y-axis. Now we go ahead and change that exponent and make it odd. Now we have it symmetric with respect to the origin, and which is 0, 0, and the domain and the range, it's the set of all real numbers. The graph is going to always contain the points 0, 0, 1, 1, and negative 1, negative 1. For example, x cubed. Okay, so we're just going to take those 3 points and we're going to plot them and move them wherever we need to move them based on what graph we have. So for example, A, we notice that the exponent is even. So that is going to be symmetric with respect to the y-axis. So you're going to think about graphing kind of like a parabola. It could, basically all we're doing right now is we are plotting these 3 points. Let me go back to the previous page. Plotting these 3 points and moving them according to the transformation. So for example, A, this has a transformation of, right here, we've got a horizontal left shift of 3, and this is going to go up, or sorry, down, right? It's a negative. Subtracting. Down. Oh my gosh. There we go. Down 2. So we're going to take those 3 points, 0, 0, 1, 1, and negative 1, 1. From the original parent function, and we are just going to shift them. So in a different color, I'm going to go left 3, 1, 2, 3, and down 2. So there we go. So there's my new 0, 0. And most of the time, I just, in my head, I kind of put, oh no. In my head, I draw myself my new x-axis and my new y-axis because that's my new starting point, 0, 0. From there, I just go over 1, up 1, and left 1, up 1, and plot my 1, 1, and negative 1, 1 from that original point. And then just draw your graph. Done. Okay. This one's got all the y values being multiplied by 1/2. And it's going right 1. So I went ahead and wrote that down. And now I'm just going to shift my 0, 0. And instead of plotting over 1, up 1, those y values are all going to be cut in half. So that point is going to be at 2, 1/2. So it's just going to be a more shallow graph. And it'll be more opened up. It'll be wider. If you take a look at B and D, we see the difference between A and B. Those are both even exponents. And these are odd. So we're just going to follow our rules, except we're going to use negative 1 rather than negative 1, 1. So this negative in front of this x to the 5th tells us we've got a reflection over the x-axis. It's just like when you are graphing negative x squared versus positive x squared. It's just going to flip over the x-axis. And then, of course, this is a plus 1, so it's going to shift up 1. So for my 0, 0, I'm just going to go up 1. And then I'm going to flip everything over my new, here's the x-axis, right? So in my head, that's my new x-axis. I'm going to flip that 1, 1 point over the x-axis to negative 1. And then this original point down here, I'm going to move that one up there. Same for D. We are going, and this is from Unit 1, right 2 and up 1, and then all the y values will need to be multiplied by negative 2. So yes, the graph is also going to flip because it's got a leading coefficient of a negative. So from 0, 0, you're going to move right 2 and up 1 to get your new 0, 0. Then in your head, you're drawing your x-axis and your y-axis from that point. From there, you're going to go, this negative makes it flip. So instead of going over 1, up 1, you're going to go over 1, down 2. And then left 1, up 2. And example 3, this is just working backwards. Sometimes they'll give you you already know that if you've got a 0 at negative 3, 1, 2, 3, right there, you're going to have a factor of x plus 3. This is just asking you to write that out. Okay, so if you've got a 0 at negative 3, and a 0 at 2, and a 0 at 5, you're going to have factors of x plus 3, x minus 2, and x minus 5, and then some number in front, we just call it a. And then a lot of times they ask you to write this out as the equation of a polynomial function, so in standard form. So just go ahead and multiply all that out. It doesn't matter which two polynomials you choose to multiply first. I just decided to multiply, this is not even my handwriting, those two polynomials out first, and then multiply this trinomial by this binomial. And then you combine all the like terms. And I just left a in front because we don't know what a is. Okay, the multiplicity of a factor is actually pretty useful for trying to draw a basic general shape of a graph, because it tells us if you have an odd multiplicity, that the graph is going to cross at the x-axis at that 0, and if it's even, then it will bounce, or sometimes we use the word touch that x-axis. So the degree of this function right here, if I were to multiply all these binomials out, I would have 5 plus 2 plus 1, right? So that's a degree of 8. So what are my x values? 2, right? Because if I set this parentheses equal to 0, I would get x is 2. The next parentheses is x plus 3, so I have an x, a 0 at negative 3. and I also have a 0 at 1/2. Okay, what's the multiplicity of my first my first factor here? That has an exponent of 1, so the multiplicity will be 1. I have 2 zeros at x equals -3. So right there, that is going to be a bounce. So if I had to draw my graph, I would know whichever direction it's coming from. At x equals -3, it's whichever direction, it's going to touch the graph and then turn around. Okay? And then at x equals 1/2, I'm going to have 5 there. All right, let's go to the next one. So this is quick review. You're just adding the exponents up. Take a look at those answers and press pause if you need to. All right, so now graphing. So here's how we go ahead and use this with graphing. So we go ahead and we look at this. We say the degree of this function is, there's 2 here plus 1. That means that's a cubic and it's positive, so it's going to be going this direction, right? It's going to be kind of looking like something like this, right? We don't know, but it's approximately. The end behavior of the graph is going to be going in definitely those directions. So now we've got a bounce at x equals 0 because there are 2 of them. And let me write that. And we only have 1 0 at 2. So I'm going to plot my zeros. I've got 0 and 2. Okay, now the graph is coming from down here. Shoot. It's coming from down here. There we go. And it's going to end up here. So it's going to bounce here, and then it's going to go through that one. And that's all we need to do. Okay, it's nice to have one additional point. If you're, I'll show you that in another graph. All right, let's go to B. So we've got a negative leading coefficient. Okay, we've got an odd graph because we've got 1 here and 2 here, which makes the degree for the entire polynomial cubic. So that's going to be negative, so it's going to be opening in the opposite direction. So it's going to be looking like this. That's the end behavior. So now, let's see. We've got a 0 at -1, and we've got 1 at 4. All right. It would be nice if I had my y-intercept, wouldn't it? Because then if I put in 0 for x, what am I going to get for y? So I went ahead and just calculated that down here. Okay, so I know my graph is going to be crossing my y-intercept at 4. So I already had it over on this graph over on the left that we did. So now with my graph starting up here, it's going to be, when we get to this 0 of -1, it's going to touch it, right? It's going to bounce there. Bounce. And then it's going to go through that point, and then it's going to cross that one. There we go. That's all we need to do. So now let's see if we can't put this together really quickly. So they're asking us to find the x and y intercepts of the graph. So the x and y intercepts are at 0, 0, -4, 0, and 3, 0. Determine the behavior of the graph of the zeros. So we only have, let's see, if I were to go ahead and factor this, that's where these zeros are coming from. Okay, so I've got 0, 0, -4, 0, and 3, 0. Okay, so determine the behavior of the graph at the zeros. It's going to cross the x-axis at all 3 zeros because we only have 1 of each. And since the leading coefficient is positive, this is what the general end behavior of the graph is going to look like. As x is approaching -infinity, f of x is going to be approaching -infinity. F of x is just y. As x is approaching infinity, f of x, or y, is going to be approaching positive infinity. See, it's going up, it's going up, it's going left, it's going down. Determine the maximum number of turning points on the graph. Okay, that's just the degree minus 1. So, turning points of a quadratic. 1, 2. Only 1, right? Here's a cubic. 1, 2, 3. There's only 2 turning points. So it's the degree minus 1. And the last piece, if you just start with plotting those x-intercepts and using the end behavior to get the graph, then you can figure out what the intervals will be below the x-axis and above the x-axis. All right, peace out.